Hello students, in this video we will see MCQs on electric potential and capacitance. So first one, if you observe, a capacitor consisting of identical plates is shown in figure. He has given distance between plates, area. You are required to find equivalent capacitance. Now just in this figure, I will take this as end A, this as end B. Now if you observe, alternate plates are connected to other ends. So now first this is connected to B, then this second is connected to A, third is connected to B, again fourth is connected to A. Like this alternately has connected plates to each other end. One B connect ಆದರೆ next A connected ಅದ ಮತ್ತು next B ಗೆ next A alternate plates one end connected. So if it is in this form, shortcut formula is equivalent capacitance or CAP is equal to n minus 1 into A epsilon naught by D, where n is number of plates, where n is equal to total number of plates. Now here if you observe, so 4, 5, 6, 7, 8, 9. So there are 9 plates. Now substitute the values in this formula. So 9 minus 1 is 8. Area he has given 5 centimeter square, means 5 into 10 raised to minus 4. Then epsilon naught is 8.854 into 10 raised to minus 12 divided by D. That is separation between plates is 0.885 into 10 raised to minus 2 as it is in centimeter. Now simplify this. In one step you will have the answer. So this gets cancelled 10 times. So if you multiply all the terms, 8 5s are 40, 40 into 10 is 400. If you simplify the power, minus 4 minus 12 minus 16 divided by minus 2 means you will have 10 raised to minus 14. So if you observe, this is nothing but 4 into 10 raised to minus 12 farad, or you can say 4 picofarad. 4 picofarad. So option B is the answer. Option B is the answer. Second one, the potential of electric field produced by a point charge at any point is given by V is equal to 3x square plus 5. He has given B. Where x, y, z are in meters, V is in volt, we are required to find electric field at this point. So relation between electric field and potential is E is equal to minus dV by dx or dV by dr. So as V is only related on x, I am taking dV by dx. Differentiate this and substitute the value of x. So if I differentiate 3x square plus 5, I will have 6x. Now substitute x value, so minus 6 into minus 2, you will get 12. So option C is the answer. Option C is the answer. Third one, the potential of a large liquid drop when 8 liquid drops are combined is 20 volt. Then potential of each single drop is. Now here, so if n number of small drops, here drops are identical. So if n drops combine and form a bigger drop, Now potential of each small drop, I will take it as Vs. Potential of bigger drop as Vb. Relation between Vb and Vs is Vb is equal to n raised to 2 by 3 divided by Vs. This is shortcut formula. So substitute the value. He has given when 8 drops are combined, so n is 8. Potential of bigger drop he has given. So 20 is equal to 8 raised to 2 by 3 Vs. Now simplify this. 20 is equal to, first you take cube root. So cube root of 8 is 2. 2 square into Vs. Therefore Vs will be equal to 20 divided by 2 square is 4. So you'll get Vs is equal to 5 volt. Vs is equal to 5 volt. So option C is the answer. Next, fourth one. The potential difference between spheres is. So now if you observe the figure. So two spheres are concentric. You are required to find potential difference between these two spheres. So I will take point A on outer sphere, a point B as on inner sphere. So if I take potential at point A, potential at point A will be both due to both spheres, potential due to bigger sphere plus potential due to smaller sphere. So if I substitute or write the formula 1 by 4 pi epsilon naught, I will take it as K. You will have common among both. For bigger sphere, A is on the surface, so you will have Q divided by R. 1 by 4 pi epsilon naught Q by R plus. For smaller sphere, A is outside the sphere, so distance is R but charge is Q. So you can think like this. This is Q. Here point A is there, so this distance is R. This distance is R. So you will have 1 by 4 pi epsilon naught small q by capital R. This is potential at A. Now similarly, if you write potential at point B, potential at point B. So at point B again potential will be due to both spheres. Due to this bigger sphere, it will be inside the sphere. We know that inside the sphere potential is same as that on the surface. So K common I will take again. If you take potential due to bigger sphere, point B is inside the bigger sphere. It is same as that on the surface. So again you will have Q by R plus. Now due to smaller sphere, for smaller sphere it is on its surface. So distance will be small r instead of capital R. So Q by small r bracket complete. This is potential at A and potential at B. So if you now calculate potential difference is equal to VB minus VA. Again you will have K common among both. K I will take outside. So VB Q by capital R plus small q by small r minus VA. So both you are required to subtract minus q by r minus small q by capital R. So here this gets cancelled. This gets cancelled q by capital R. So you will have answer 1 by 4 pi epsilon naught into bracket q by small r minus q by capital R. Now check the options. In numerator both q are small. So if you see in option C we are having divided by small r and capital R. So C is our answer. C is our answer. Next, fifth one. The charges are placed at the vertices of an equilateral triangle. Net potential energy of the system is 0, he says. Now students, here you can remember this shortcut. What he says, potential energy, net potential energy is equal to 0. So if you write expression for potential energy, 1 by 4 pi epsilon naught common you will have, or I can say K, summation Q1 by Q2. As it is an equilateral triangle, distance between two charges will be same. So if I take side as x, this is equal to 0. For all three x will be same, 1 by 4 pi epsilon naught will be same. So when he says equilateral triangle, potential energy is 0. Directly you can take summation Q1, Q2 is equal to 0. This you can take it as a hint or shortcut to solve. Now substitute. You take cyclic product of charges capital Q into small q plus small q into small q plus again small q into capital Q will be equal to 0. Now take small q common, it will go on that side, so you'll have q plus small q plus capital Q is equal to 0. You are required to find capital Q, so you'll have 2q is equal to minus q. Then finally q is equal to minus small q by 2. So check the option. So answer C. So option C is our answer. Next one, sixth. The energy stored in the capacitor system shown in the figure is. So if you want, you can rotate this figure by 90 degree and observe these two are in series first. These two are in series. So if I solve this, 6 into 3 by 6 plus 3 is 9. So 18 by 9 means you will have 2 microfarad. Now this 2 and solved 2, these two are in parallel. Therefore equivalent capacitance C will be 2 plus 2, that is 4 microfarad. Potential V is 2 volt. Now you calculate energy. So energy is equal to half CV square. Substitute the values. Half C is 4. Potential is 2 square. So if you simplify 2, so 4 into 2 will have 8. So capacitance is in micro. So energy will be in microjoule. So 8 microjoule. Option A is the answer. Option A is the answer. Next, seventh one. When an additional charge of 2 coulomb is given to a capacitor, energy stored in it increases by 21%. Then original charge you are required to find. So now first original charge Q1, I will take it as Q. So additional charge when I give, so Q2 becomes Q plus 2. 2 coulomb is additional which I am adding. What he says, the energy increases by 21%. Initial energy I will take it as 100 as he has given it in percentage. Means final energy will be 21% more, means it will be 120. You are required to find value of Q. Value of Q. Now, if I take formula of energy, energy stored in capacitor is given by half CV square. Half CV square. So C is constant. As the charge changes, V changes. So I will replace V. So if I remove this V, that is C is equal to Q by V. So V is equal to Q by C. So if I replace, I will have half C Q square by C square. 1 C gets cancelled, or I will take it as U is directly proportional to Q square. Now take the ratio. If you take the ratio, you will have the answer. So U1 by U2 is equal to Q1 by Q2 bracket square. Substitute the values. 100 by 121 is equal to Q1 is Q, Q2 is Q plus 2 bracket square. Bracket square. Now, if you observe, LHS is also perfect square. So, taking square root. So, take square root on both sides. So, take square root. So, if you take square root, you will have 10 by 11 is equal to Q by Q plus 2. Q by Q plus 2. Cross multiply, you will have the answer. 10Q plus 20 is equal to 11Q. So 10Q, if I take on that side, I will have 20 is equal to Q. So Q is equal to 20 coulomb. So option D is the answer. Option D is the answer. Clear, students? Next, eighth one. A small oil drop of mass 10 raised to minus 6 kg is hanging in at rest between two plates separated by 1 mm. So there are two plates separated by 1 mm. So I will take this as one plate. And there is another plate we are having. So a small oil drop. So oil drop is there. So its weight, that is W is equal to mg, is acting downward. It is hanging at rest means in opposite direction there is a force acting due to electric field. So due to force, that force F is given by Q into E. So this is positive plate, this is a negative plate. So there is a force acting in opposite direction, because of which that drop is at rest, or it is hanging between two plates. You are required to find charge. So if we equate these two, that is F is equal to W, or you can say QE is equal to mg. So E here is not given, but we know the relation between E and V. So I will take Q, E I will write it as V by D is equal to mg. So we are required to find the charge. So Q is equal to mg into D by V. Now substitute the values. Mass 10 raised to minus 6 kg. G I will take it as 10. Separation between plates is 1 mm, means 1 into 10 raised to minus 3, whole divided by V. V is 500. So simplify, you will have the answer. So 1 0 gets cancelled. So this is 1 by 5 into 10 raised to minus 9. This 1 10 will go to the numerator, you will have 10 raised to minus 10. So 1 by 5 is 0.2 into 10 raised to minus 10. Now observe the options. So 0.2 into 10 raised to minus 10, or you can say this is 2 into 10 raised to minus 11 coulomb. So option B is our answer. Option B is our answer. Next, ninth one. Two metals spheres of radii 0.01 and 0.02 are given a charge of 15 millicoulomb and 45 millicoulomb respectively. They are then connected by wire. The final charge on the first sphere will be. So when two metal spheres are connected by wire, there will be redistribution of charge. There will be redistribution of charge. So as asked on first sphere. So initially charge on first sphere is 15 millicoulomb. That on second sphere is 45 millicoulomb. Radius of first sphere is 0.01 meter. Radius of second sphere is 0.02 meter. Has asked final charge on first sphere. So shortcut formula is Q1 dash, that is final charge on first sphere, by initially charges on that Q1 plus Q2 will be equal to R1 by R1 plus R2. R1 by R1 plus R2. Now substitute and find the Q dash. In one step you will have the answer. So Q dash divided by Q1 plus Q2, 15 plus 45. 15 plus 45 will be 60 in millicoulomb. R1 is 0.01. If you add both, you will have 0.03. So Q dash is equal to, or Q1 dash is equal to, if I cross multiply 60, this if I remove zeros, it is 60 by 3, that is equal to 20 millicoulomb. So charge on first sphere after connecting both will be 20 millicoulomb. So option C is our answer. Option C is our answer. 10th one. A voltmeter reads 4 volt when connected to a parallel plate capacitor with air as a dielectric. So I will denote it as VA as a 4 volt. Now when dielectric slab is introduced between plates of same configuration, means dimensions and all remain same. So voltmeter reads 2 volt. I will take it as VM 2 volt. You are required to find the dielectric constant. So we know that epsilon R is equal to Cm by Ca. How C and V are related? C is equal to Q by V. So inversely proportional. So here you will have VA by Vm. Now substitute. VA is 4, Vm is 2. So dielectric constant is 2. Option D is the answer. Option D is the answer. Next one. 11th. A parallel plate capacitor is charged and then isolated. So it is charged and then isolated, means it is removed from battery, or battery is disconnected. So battery is disconnected. Battery is disconnected means charge remains constant. So Q remains constant. Q remains constant. The effect of increasing the plate separation on charge, potential and capacitance. So now D is increased, that is distance between plates. So when it is isolated, charge remains constant, so first charge is there, so A is not the answer. In all other three, first term is constant, so we are required to solve. Now if I take capacity, C is equal to A epsilon naught by D. So here C is inversely proportional to D. C is inversely proportional to D. So therefore, as D increases, C decreases. So check, we know in which all capacitance decreases. So in B it is decreasing, in C it is decreasing, in D has given increases, so D is not the answer. Now either B or C. Now potential we are required to find. So C is equal to Q by V, V is equal to Q by C. So Q is constant, V is inversely proportional to C. So above we have seen C is decreasing. So as C decreases, V increases. So V has to increase. So C is not the answer. Our answer is option B. Our answer is option B. Clear, students? Next, 12th one. A system of two capacitors, 2 microfarad and 4 microfarad, are connected in series across a potential difference of 6 volt. You are required to find charge and energy stored in the system. So two capacitors are connected in series. So first I will find equivalent capacitance. So 2 into 4 divided by 2 plus 4 is 6. So you will have 4 by 3 microfarad. So potential is 6 volt. So I can find Q. Q is equal to C into V. Q is equal to C into V. So if I substitute, C is 4 by 3. V is 6. So if you simplify, 3 to the 4 to the 8 microcoulomb is the charge. If you observe the options, in only B option we are having 8 microcoulomb. So answer is B. You need not find energy. Even if you find, you will get it as 24. 13th, 2-point charges 3 and 1 are placed 5 cm apart in air. Work done to move charge B towards A by 1 cm. So when we move by 1 cm, the distance between them becomes 4. So first case I will take. First, here I am having 3 nanocoulomb, 1 nanocoulomb. Distance between them is 5 cm. So there are two charges. So initial potential energy will be equal to 1 by 4 pi epsilon naught. I will take it as K. Q1 into Q2 will be 3 into 10 raised to minus 9. Minus 9 means minus 18. 3 into 1, 3. Nanocoulomb is there. So minus 9 you will have minus 18 by 5 into 10 raised to minus 2. Q1 into Q2 by R. So this is equal to K 3 by 5 into 10 raised to minus 16. Now they are moved 1 centimeter nearer towards each other. So now this is 3, this is 1. The distance between them now it becomes 4 as they are moved 1 centimeter nearer. So now potential energy of this will be again K, numerator remains the same, minus 18, denominator changes 4 into 10 raised to minus 2. So you will have K 3 by 4 into 10 raised to minus 16 joules. Now work done you are required to find. So work done or work is nothing but the difference in this energy. By work energy equation you can say. So final energy minus initial energy. So again I will take a common. K into 10 raised to minus 16 is common. So final means 3 by 4. Initial means 3 by 5. 3 by 5. So if I simplify this, K is 1 by 4 pi epsilon naught 9 into 10 raised to 9. This is 10 raised to minus 16 into. If I simplify this, you can take LCM or I will convert it into points. 3 by 4 is 0.75. 3 by 5 is 0.6. Now simplify, you will have the answer. So this is equal to 9 into 10 raised to. So plus 9 minus 16 means you will have minus 7 into. If you subtract, you will have 0.15. 0.15. So if you multiply 9 into 0.15, 15 nines are 135, so you will have 1.35 into 10 raised to minus 7 joules. So option B is our answer. Option B is our answer. Clear, students? Next one. The minimum value of effective capacitance that can be obtained by combining the three capacitors of capacitance 1, 2 and 4 picofarad. So minimum value of capacitance you will get when they are connected in series. So when you connect them in a series, you will have minimum capacitance, and this minimum will be less than smallest of all. Less than smallest of all capacitors. Now here if you observe 1, 2 and 4 means the smallest is 1. So equivalent will be less than 1 picofarad. In options less than 1 picofarad we are having only one option, that is B. So answer is B. Answer is B. Next 15th. Effective capacitance between A and B. So this is very easy. Now if you closely observe the figure, if I take these points C as this point, up till here there is no capacitor, so potential is same. So these 3 points I can combine. Similarly, below if I take these 3 points, I can combine. So here I am having A, here I will take it as B. So C, D. So from A to C we are having one capacitor, that is 4. A to D we are having 1, that is also 4. This and this I have taken. C to B we are having, that is 4. And from B to D we are having 1, that is 4. Now this 20 is in between C and D. This is 20. So the given figure is nothing but Wheatstone's network. And if you observe, it is balanced and all capacitors in arms are same. So CAB will be equal to C, or you can say that is 4 microfarad, as it is balanced. So option A is the answer. Option A is the answer. Next one. Two metal plates are separated by 2 centimeters. So he has given D. Potential of one plate is minus 10 and one plate is 30. So if I take this is at 30 volt. If I take another plate, it is at minus 10 volt. Distance between them is 2 centimeters. You are required to find E. So relation between E and V we know. In options all are positive, so I will take dV by dx magnitude. So dV means difference in potential, that is 30 minus of minus 10. Distance between them is 2 centimeter, 2 into 10 raised to minus 2. Now simplify. This will be 40 divided by 2. This 10 raised to minus 2 I will take to the numerator. So 40 by 2 is 20. These two zeros you will have 2000 volt per meter. So option A is the answer. Option A is the answer. Next, 17th. Equivalent capacitance between A and B is. Again, closely if you observe the students, without solving you can have the answer. Now this B, you imagine that you are holding it in hand and you are pulling it towards clockwise direction. If you pull it in clockwise direction, you will have 50 over here. So this is B. You will have 50 picofarad over here. So this 50 is in series with these 3. Means your simple circuit will be in this form. You will have simple circuit in this form. This is B, this is A, this is 50 picofarad, these two are 100 and this is 50. You are required to find equivalent capacitance. Just in previous problem I had told 2 problems back. Now in series, equivalent will be less than smallest of all. Means this 50 and smallest of this equivalent. So smallest means it will be less than 50, you can say. Now observe the options. D is only option which is less than 50. So option D is the answer. Even if you solve, you will have same answer. Next, 18th. A particle of mass m and charge q is placed at rest, means initial velocity is 0. In uniform electric field E and released. Kinetic energy attained by particle after moving a distance y. So for kinetic energy I need V. So I will use basic formula V square minus U square is equal to 2as. So V square is equal to, this is 0, 2, A is QE by M, acceleration is QE by M, that is force by mass, distance travelled is y. So I want kinetic energy. M and 2 I will take to the LHS. So it will be mv square. 2 I will take to the LHS 1 by 2. Remains is QE into Y. So half mv square is nothing but kinetic energy. So QE into Y. Option A is our answer. 19th. The difference between equivalent capacitance of two identical capacitors when connected in parallel to that in series is 6 microfarad. So what he has given, Cp minus Cs is equal to 6. So two are there, identical are there, so equivalent in parallel will be 2C, in series it will be C by 2 is equal to 6. Now one step you simplify, if I take LCM it will be 4C minus C is equal to 12. So 3C is equal to 12, so you'll have C is equal to 4. Option A is our answer. Lastly, a dipole of dipole moment P and moment of inertia I is placed in an electric field E. It is slightly displaced from stable equilibrium position. The period of oscillation of dipole is, you are required to find T. You are required to find T. So direct formula is there. So T is equal to 2 pi root of I by P. So option D is our answer. Hope this video will be helpful to you students. So request you to share this with all your friends so that it can help them also.